In this exercise, let's study abstract class. Let's create an app, Kotlin Abstract Classes. No backward compatibility. So what we are going to do is we are going to define two classes, rectangle and circle. And we want to represent those shapes on two-dimensional coordinate system. So as we learned from object-oriented programming paradigm, we can pick up some commonality among rectangles and shapes and then put in some kind of a fake superclass that could be an abstract class. So let's create a package for model package. Within there, let me create a Kotlin class called myShape. It's a class, so we say class myShape, and then primary constructor. So it's a common things between circles and the rectangles. So let's pick up XY location as common. So in primary constructor, we define X double and then Y is double as well. So like Java, in each member you can define accessibility. So we just use it protected, so meaning that subclasses can have access to this member directly. So this one protected as well. Then let's begin class definitions. Also, we want to have a constructor, so which takes no parameters at all. Then we assume default values x0 and y0. Then we could do that using secondary constructor. So constructor. Then we do not take any parameter. Then which means 0, 0. So we have a primary constructor there. So we need to call it using this 0 and 0 is there. So but in this secondary constructor, the body of the function is nothing. Then in Kotlin syntax, then if we don't do anything, it's just empty body, then we can just omit the curly braces. So here, an empty curly brace as a function body is not required in Kotlin. So we have a concise syntax. So one of the common behavior would be move to a different location. So move to, and then we provide a target location of xy. Then this x becomes x, and this y becomes y. That's the move to function. Another function we could think is translate. Translate is by given amount of delta x and then given amount of a y change is just relocated by this given amount. It's not a target location, just a change to that amount. Then we could say delta x is whatever provided, and then y location is updated by the amount provided. So the translate, as you remember, translate is computer graphics terminology. Then we want to have a common behavior called the get area function, but this function cannot be defined in myShape because we don't know the shape specifically yet. Then this one deserves a abstract function like Java. When a class has abstract function, then whole class should be abstract. So same requirements in Java. So we have defined the myShape as abstract class, which has one abstract method called getArea. Now using this one, let's define circle and rectangle. So in the model, let's create Kotlin class. Now let's choose class. Then here, let me define rectangle class. So rectangle class is a subclass of my shape. So inside the parentheses, first we need to define primary constructor. Primary constructor, we are going to receive x value, y value, width and height. So x double, y double. So those are the ones we are going to store in its rectangle's parent class. So here, superclass or parent class, the definition is given in after colons. In Java, we use the extends, but we use a colon, and then my shape will be parent one. It's not complete yet, so we'll complete that shortly. And then in the primary construct of a rectangle, we want to also have width and height. So var width is double type, var height as a double type. So notice that as we give a keyword the var within primary constructor syntax, and now we are adding this one as a new member variable of a rect class. So notice that in x and y we didn't give a keyword var, means those are just the function parameters. So we will forward it to, so let me give a line break, and x, y we are going to forward it to xy. So x and y are not the member variables of a rectangle, but just the value we are going to receive. But if you define the primary constructor parameter with the keyword var, means that now those are member variables now added to rectangle class. That's the meaning of that. So here the superclass construct is called, and that is all provided. Now let's provide a secondary constructor which takes width and height only. Then default value of x and y is 0. Then we could do width double, height double. That's only provided. Then this constructor we just call 0, 0 for x and y. Then width and height we can just forward it to the primary constructor. Remember, keyword this is for primary constructor. So that's a secondary constructor there. Also remember that if the body of the function is empty parenthesis, we can simply omit that, as I showed in the previous my shape class. Then still we have error, because the error is that abstract function, abstract methods are not overridden yet. So here rect class is a subclass of my shape. My shape is abstract, have a one abstract method, so subclass should override that abstract function. So override function get area, we should override that. So in this, what we want to do is return area of a rectangle is width times height. So we also know that single expression function, so we could simply give a equal sign for that. So function overloading is done. Also, eventually we are going to display those objects of rectangles or circles on a list view. So let's have some string representation of this rectangle class. To do so, we need to override toString method. In this also, we are going to use a single expression. So single expression is this is a rectangle class. And it has a x and y location, x and y location, which is from my shape, but as you remember, my shape X and Y are protected members, so I have a direct access to that. And then width and height. So width is width, height is height. There. I have to override there. So fix that. So rectangle class is completed. Now let's create another class. So circle class. Let's create that. In circle class, similarly, primary constructor has a xy value, which will be stored in its superclass, and then its own member variable is a radius of the circle there. Then it's my shape is parent1, and x and y are forwarded to its parent. Then secondary constructor, we want to take radius only. Then we could forward 0, 0 as xy, and then radius we could forward to the primary constructor. Then we need to override get area function. Get area, single expression should be sufficient, so we provide area of a circle pi times the radius, and radius. So pi is in method class. It's a pi constant. Pi times radius is area. Also, let's override function toString method. toString. Also, let's do single expression. That is a circle. And then xy is x, y. Radius is there. So let's test in main activity those classes in hierarchy of classes we created so far. So let's create a member variable, private, an array of shapes array is a array list of my shape there. Then using a loop for I in 1 to 10, let's add shapes and circles like rectangle class. Let's provide alt return to import the rectangle. So x, y, and width and height. Let's do that. And then those ones are double type, but here I is integer type, so we need to change it to double. So let's have a val d is I to double. Then here you could give a d. Then a rectangle is added. Oh, class name is rect. Sorry for that. So rect is the class name. Import that. So rectangle is here, as you can see, one of the libraries, so that's why it worked. But now this is correct one. Now shapes array, let's add a circle class, alt return, circle class is added, so x, y, radius, just for simplicity's sake, we do that. Then let's print the contents of a shapes array using a log mechanism. So let's have a loop, shape in shapes array. So now a variable s is a shape object. What I'm going to do is log dot information. The tag I'm going to define shortly, and their message is whatever s is. Now at this moment, the in string template expects $s as a string. Then we have defined in rectangle and circle two string methods. So at that moment, two string method will be called. For log class, alt enter, so that's imported. The tag we need to define const val tag. Let's define as abstract class, something like this. Then let's run the program. Let's open up the logcat window. We see lots of messages. So let's filter with abstract class. Its name is abstract class, like then what we get down here is as follows. So rectangle, the first one, one is a rectangle, circle, rectangle, circle is there. So here, as you can see, we only display S, which is shape type, but through polymorphism, whether it's a rectangle or circle, it goes down to that corresponding subclass, and then the toString method is called and the corresponding messages are displayed. So polymorphism is utilized to call toString method. So to make it explicit, you may write this way: toString method. Then when you use a function call in the string template, we need a curly brace. Otherwise, $sign is applicable only to S1 only. So because of operator precedence, we need to put curly brace. Then the function call is done and the result will be displayed. So polymorphism is utilized at this moment.